Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's take a look at our homework for lesson 7.1.4. The M&Ms for this particular homework is titled Scaling. And scaling is what we were talking about when we were multiplying, scaling up or scaling down a quantity, and we were applying it to percents in previous lessons. So if you want to take, for example, this situation, if a music system is on sale for 25% off the original price, we are going to scale this, the discount, converting 25% into a decimal number, 0.25. You multiply that times 500, and this quantity is going to give you the amount of the discount. So it's going to be $125 off, right? That's the discount. If you want to find the new price, the sale price, we're going to have to choose the complement of 25%, which is 75%. So if you consider the original price, the 100%, then 25% is the discount, 75% must be the sale price of what you're going to pay. So we'll multiply 500 times 0.75, which is equivalent to 75%, to give you the sale price. So if in one step you want to find the amount of the discount, choose 0.25 as your scalar. If you want in one step to find the new price, the sale price, use 75% as your scalar. All right, so Mr. Anderson's doctor has advised him to go on a diet. He must reduce his caloric intake by 15%. He currently eats 280 calories per day. Calculate this in two different ways. All right, so once again, let me just show the diagram here to make sure we're all on the same page. What is it? 1, 2, 3, 4, 5. We can do it like this. No, actually, let me do it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We'll do it like this. Now choose that. This represents 0. This represents 100%. And so if we break this up into 10% intervals, each one of those is equal to 10%, and each one in the middle would be 5%. So we're going to take the full 2,800 calories, and if we want to find 15% of it, we're going to find this section right here. That represents 15%. So if I multiply 2,800 times 0.15, this is going to tell us how many calories needs to be reduced. Let me actually change this and put that down here. This is 15%, so that's going to be a total of 420. If we want to find how many calories that he actually should consume now, after reducing 15%, then we want to find 85% of this total, which ends up being 2,380. So the quantity from here to here is 2,380, which represents 85% of what, stop it, get out of the way, 85% of what he normally would have been having per day, okay? So use two different scalars, one if you want to find the amount that he needs to reduce by, the other if you want to find the new amount. I need to pause because I got to plug in my computer. Hold on. All right, moving on to the next problem. This is a word problem, so sure enough, let's use a 5D process to help us solve this problem. Last month, a dwarf lemon tree grew half as much as a semi-dwarf lemon tree. A full-length lemon tree grew 3 times as much as the semi-dwarf lemon tree. Together, the 3 trees grew a total of 27 inches. Write and solve an equation to determine how much each tree grew. All right, so let's read this again. You got a dwarf lemon tree that grew half as much as a semi-dwarf lemon tree, and then you've got a full-size lemon tree that grew 3 times as much as the semi-dwarf lemon tree. Since both the dwarf and the full-size lemon tree are both being compared to the semi-dwarf, we should make the semi-dwarf x. That would make the dwarf lemon tree 1/2 of x, because it grew by half as much, and it would make the full-size lemon tree 3 times x. Now, this is going to require all of us to use either decimals or fractions as coefficients. So what if I were to consider doing this instead? What if I chose to make the dwarf lemon tree my x? So if that's half the semi-dwarf, then this would become 2x, and this is 3 times the semi-dwarf, which would make this 6x. Is it legal to do this problem where these are our definitions instead of these? Let's check. If I took x, 2x, that's 3x, that's a total of 9 x's, and the total was equal to 27, correct? That means x is going to have to be equal to 3. Since 9 divided by 9 is 1, and 27 divided by 9, that's supposed to be a 9 there. Sorry, hold on. Not a G. That would be 3. And is that what we're saying? That means x, which is the dwarf lemon tree, would be 3, which makes this guy 6. And that's what we said there was 6, which would make this guy 18. And all together, 9 and 8, that's 7. That's 27. Yes, that works as well. So it really doesn't make any difference which one of these variables you choose to make your x. As long as the others meet the definitions and how they're compared to whatever you make as x, everything is fine, right? This was x, that's half of x, that's 3 times x. Well, that's half of x too. If you consider this is 2 x's and half of that is 1x, and then 3 times 2 is 6 x's. You can define them in slightly different ways, but as long as they all fit with the descriptions written up here, then everything should be fine. In fact, I might even say that this is giving us a preview of what we're going to be doing in our fraction busters, where if we just multiplied every single one of these guys times 2, we would be able to get rid of that decimal number there and solve things a little bit easier. And then we can stick with these as our definitions. So lots of different strategies that you can use. The more you do this algebra and you do this problem solving, the more you're going to see that, hey, there's some shortcuts here. This will make my job easier. And then you'll get your answers much more quickly and easier. All right, Enrique is saving money to buy a graphing calculator. So far, he has saved $30, and his math teacher told him that he has so far saved 40% of what he needs. So 40%, 40%. There we go. Section from here to here, if we scale this number line into 10% intervals, this is 20%, that's 10%, this is 40%, and 30 is equivalent to 40%. So that's 2 big sections there. If 2 of those equals 40, then each one of them must be 20%. And that means 20% must be equal to 15. And 10% would have to be equal to half of that, which would be 7.5, and blah, 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 blah. I'm rambling on, just thinking out loud. But this gives us enough information to solve the problem. It tells us if each one of these is 15, then 5 times 15 gives us 75 for an answer. And so that's going to be how much the calculator costs. And I can test that by using my understanding of scaling now. If I take 40% in decimal form times 75, I should get 30 for an answer. And let's prove that that's true. 75 times 0.4, is that equal to 30? Yes, it is. Okay. Now, this is my preferred method. Taking this situation and setting it up using the percent proportion. Remember, the part over the total is going to be equal to the percent out of 100. This whole process of multiplying a decimal number times the total is when you're trying to find the part. It doesn't work when you've got the part and you're trying to find the total. The most common wrong answer people are going to make here is they're going to take 30 times 0.4 and they're going to get something like 12. But 12 is not the total. If 40% of the calculator's price is $30, the total price can't be $12. And you'd be surprised at the number of people that don't even think twice. They just write $12 and move on because they're not even thinking about the logic of the problem. So we've got to have some other approach to use here, and that's where I like using the percent proportion. So this represents the part of the cost. The total we don't know, and the part that we're talking about corresponds to 40%. So is there a giant 1 that we can see there? Not really. Maybe we just cross multiply and say 40x is equal to 3,000. And now when you take 3,000 and divide it by 40, you should get your answer. 3,000 divided by 40 is indeed $75. Okay, so big fan of the percent proportion. If there's ever any confusion about these other strategies we've been working with, always fall back to this. It works like a charm. All right, a principal made the histogram at the right. Analyze how many years teachers had been teaching at her school. How many total teachers have been here? Okay, well, this is the frequency, which means there are a total of 7 teachers that have been there between 0 and 5 years. And by the way, I think I've said this once before, but I'll say it again. A teacher who has taught for 5 years, that goes into this bin here. 0 goes into this one, 10 goes into this one, 15 always goes into this one, and 20 always goes into this one. But we don't know the individual years that they've been teaching because that's not provided in the histogram. We just know that 7 teachers here, 10 teachers here, 4 teachers there, 1 teacher here, and 2 teachers there. So when we add all those together, you get 24 total teachers. So if the principal randomly chose 1 teacher to represent the school at a conference, what is the probability that the teacher would have been teaching at the school for more than 10 years? Okay, so I would say 10 or more years is the better way to describe that, because there could be someone in this bin who has been there for 10 years. So 10 or more years. So that would be 4, 5, 6, 7. So that's 7 out of 24, which to convert that to a percent, 7 divided by 24 gives you the decimal number of 0.2916 repeated, but if you move that 2 decimals to the right, you get 29%. So that's like 29 hundredths, 29%. Then it says, what is the probability that a teacher on the staff has been teaching for fewer than 5 years? Well, all of these are fewer than 5 years. Because if they were 5 years, they would go in here. That's also 7 out of 24, so that's also 29%. All right, Lou is rolling a random number cube. The number cube has 6 sides. Each one is labeled for the numbers 1 through 6. What's the probability that he will roll a 5 or a 3 in one roll? Well, here's a 5, there's 1 5, and there's 1 3. So 2 out of the 6 qualify as either a 5 or a 3, so that's 2/6, or simplified down to 1/3. What's the probability that he will roll a 5 and then a 3 in 2 successive rolls? All right, so the difference between these problems, this one uses the word or, which means we're going to add 1/6 plus 1/6, gives you 2/6 that we simplify. This one uses the word and, which means you're going to multiply. So the probability of getting a 5 is 1/6. The probability of getting a 3 is 1/6. The probability of on your first roll getting a 5 and then on the very next roll also getting a 3 is a lot harder. So you multiply those together, and that's how you get the 1 out of 36 chance. And then what's the probability that he will roll a sum of 12 in 2 rolls? Okay, how do you get a sum of 12? Well, let's figure out what all the possible combinations are. You could have a 1 and a 1, which is equal to 2, right? You could get a 1 and a 2, which is equal to 3. You could get a 1 and a 3, which is equal to 4. And you could keep doing this, but you know what? How are you going to get a sum of 12 unless you roll a 6 and a 6? There's no other possible combination. So only one out of all the possible combinations is going to give you a sum of 12. And if you figure the total number of possible rolls, you've got a 1 in 6 chance of getting a 6 and another 1 in 6 chance of getting a 6. So that's kind of like this right here. You got a 1 in 36 chance of getting a 6 and a 6 to get a 12, which means you got a 1 in 36 chance of rolling double 6s. All right. Checkpoint problem. At this point of 7th grade math, you are expected to be able to combine like terms, whether they are positives or negatives. So let's go through, count up all of our x squareds, let's add up all of our x terms, and let's add up all of our constant terms. 4x squared and negative 2x squared, remember you add the coefficients together. 4 plus negative 2 is positive 2. 3 plus negative 2 is positive 1. And negative 7 plus negative 3 is negative 10. So this is the simplified version of that expression. Here we do the same thing, negative 3x squared and positive 4x squared, negative 2x squared and negative 7x squared, and positive 5 and positive 6. Those are the like terms. Add negative 3 and positive 4 to give you 1x squared. Add negative 2 and negative 7 to give you negative 9x's, and add 5 and 6 to give you 11. So x squared minus 9x plus 11 becomes the simplified version of this expression. And that does it for our homework. Hooray! Let's move on to our next activity.
Hey, feeling good, like I should.